Hello, this is Jennifer Martinez, and in this video I'm going to show you the proof of the quotient rule, and I'm going to use the product rule to do so. What is the quotient rule and what is it used for? Well, it's used to find the derivative of the quotient of two functions. And what is it? Well, if u is equal to f of x and v is equal to g of x, and they're both differentiable, then the derivative of f divided by g, that's what the left says there, is the derivative of f times g minus f times the derivative of g all over g squared, believe it or not. Again, a common mistake would be just the derivative of the top divided by the derivative of the bottom. It's just not so, and we will see in our proof in a minute. Okay, or equivalently in our alternate form, the derivative of, with respect to x, of u and v, because both of these are respect to x, is the derivative of u times v minus the other way around, u times the derivative of v. We have a minus there, unlike the product rule where there's a plus, and we have to also divide by that v squared. So in words, the derivative of the quotient is the derivative of the numerator times the denominator minus the other way around, the numerator times the derivative of the denominator all over the denominator squared. Or you can say the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, let's go ahead and prove it. What I'm first going to do is I'm going to let some other function, the book uses q, so let's go ahead and do that, to be the f of x over g of x that I had over there. And then I can multiply both sides by g of x, and I have the product of two functions. So instead of using the limit definition of the derivative, now I'm just going to take the derivative of both sides, the derivative of the left and the derivative of the right. I'm going to put the f of x first, so I'll say the derivative of the f of x, that's what is equal to the derivative of this q times g. The left side is just f prime of x. We'll use the original notation. And this we know from the product rule. I proved it in the last video. The derivative of the product of two functions is the derivative of the first times the second plus the first times the derivative of the second. So I'm going to do that with these letters. So I'm going to take the derivative of the first, that is a prime there, times the second, plus the other way around, q of x times g prime of x. So what we're after is the derivative of q. So I'm going to now solve for q. I mean solving for q prime. We're after the derivative of q, which is the q prime. So if I solve for q prime here, I'm going to subtract this term over. So I have q of x, g prime of x is equal to q prime g. Again, I can put this on the other side, but one more minute. Let's divide both sides by g of x. And so what I have here is these cancel and gives me q prime of x. I'll put it on the left, and I'll just rewrite the right. So I don't want my answer in terms of q of x. So if you remember, q of x was just f over g. That's what I originally started with. So I'm going to say this is equal to f prime of x. Change q to f of x over g of x from my first line up here. And then I'm going to still have that g prime of x, still have that g of x. Don't like the double fraction, so I'm going to multiply both sides by g of x. That's where that squared comes in. So what do we have? This is it. We have, drum roll, we have f prime of x multiplying this over g of x minus the g of x cancels here, so we have f of x, g prime of x, all over the bottom squared. Is that it? Let's see if that was the quotient rule. Let's make this really small. F prime g minus f g prime all over g squared. That's it. If you rather the other notation, you could say that we have the derivative of x of u over v, which by the way is the same thing, because if you remember, u is equal to f of x and v was equal to g of x, and that was my q prime. So now if I just put these all with u's and v's, that would be u prime v minus u v prime all over v squared. Again, the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Hope that helps.